So now we're going to move on to multiplying rational expressions. When multiplying rational expressions, there's this four-step process to kind of guide you through these problems. The first is to factor all numerators and denominators completely, so get everything as factored as much as you possibly can. Then you'll divide out any common factors of the numerators and denominators. So really what we're doing here in steps 1 and 2 is we're simplifying our rational expressions. Once they're in simplified form, let's multiply straight across, multiply numerators, multiply denominators, because that's how you multiply fractions. Then just double check that you don't have any new common factors, and if you do, divide them out, and if you don't, then you're all done. So let's give this a shot. Example 4, multiply and assume all expressions are defined. Okay, so this piece here means that we don't have to go and identify values for x that can't equal. So this piece that says assume that all expressions are defined is just telling us we don't have to set the denominators equal to 0 and figure out what x can't be. We can skip that part. So all we're going to focus on is the simplifying and the multiplying. We don't have to worry about setting the denominator not equal to 0. Okay, so step 1, let's simplify each of these fractions individually. Now, notice how we have these like single monomials, right? These single term pieces in all of our numerators and denominators. So what I'm going to do is I'm just going to go fraction by fraction and simplify each of them individually and then multiply straight across. Some of you might feel like you're a little bit more advanced and could do what's called cross division, and you do that cross division first and the simplifying all in one step, and that's perfectly okay. Alright, so let's get started. Looking at this first fraction, I'm going to break it down by first looking at my constants and then my variables. So I have this 3 over 2. That can't be simplified at all, so it's just going to stay 3 over 2. Alright, next, and I'm actually going to stick to using highlighter. Let's look at the x variable. I have x to the 5th over x cubed. Well, I subtract those exponents with a common base, so the difference between 5 and 3 is 2. X to the 5th was in the numerator, which was the higher exponent, so I know that the difference between those exponents is going to go in the location of where the original largest exponent was. So x squared will go in the numerator. Next, I have y to the power of 3 divided by y to the power of 7. The difference between 3 and 7 is 4. Now, the larger exponent was in the denominator, so I'm going to take the difference between those exponents, and that's going to go in the denominator where the original larger exponent was located. So now that I've simplified this first fraction, let's go on to the second one. So we times. All right, I have 10 over 9. That can't be simplified at all. Then I have x cubed over x squared. That simplifies down to just x to the power of 1 when I subtract those exponents. Then I have y to the 4th divided by y to the 5th. Difference between those exponents is 1, and I put that in the denominator. Now that I've simplified my fractions individually, I'm going to multiply straight across. So multiplying straight across is going to give me 3 times 10, which is 30. X squared times x, which is x cubed. 2 times 9, which is 18. And y to the 4th times y to the power of 1, which is y to the power of 5. Looking at my 30 divided by 18, 30 and 18 can both be simplified down. And that's going to give me 5x cubed over 3y to the 5th, because they can both be simplified down by 6. So that's going to give me my final answer. All right, let's take a look at example 5, which is divide. Remember, when you're dividing two fractions, that's the exact same thing as multiplying by the reciprocal of the second fraction. So let's start this method by first converting this division problem into its multiplication form. So I'm going to have 5x to the 4th over 8x x squared y squared times, I flip the second fraction, 8y to the 5th over 15. Now you might be thinking, why don't we do a couple things in one step, Mrs. Walker, and do some simplifying and rewrite this as multiplication all at once? And you definitely can, but I'm going to take this one a little bit slower because it's our first. All right, now looking at our problem, I have 5 over 8. That cannot be simplified at all. So that is going to stay the same. Then I have x squared over, or x to the 4th over x squared. And that's going to simplify to x squared, where the x squared goes in the numerator. The y squared doesn't have anything to simplify from it, so it's going to stay the same. And in the second fraction, there's nothing to simplify here either. 8 and 15 don't go into one another, and y to the 5th has nothing to simplify with it as well. All right, I'm going to multiply straight across. 5 times 8 is 40. Then I have x squared y to the 5th. 8 times 15 is 120. And then I have y squared. Doing a little bit of simplifying, 40 and 120. Well, 40 goes into 123 times, so that's going to leave me with a simplified fraction of 1/3. X squared has nothing to simplify with, so it's going to stay the same. Y to the 5th over y squared is going to simplify into y cubed, which will go in the numerator. So we get 1 times x squared times y cubed all over 3. Now you could leave your final answer like this, or you could write it as x squared y cubed over 3, and it means the same thing.